Paro University. A very good morning to everyone. Our expert for today is Dr. Devbhadra Sir from Veer Narmad South Gujarat University. I welcome you, sir, on behalf of Paro University team. I will give a brief introduction about our expert. Sir has published more than 69 research papers in national and international journals, 32 articles in pedagogical journals, and edited and co-authored 6 books. 7 students have been awarded PhD degree under him, 8 students are awarded MPhil degree under him, and 5 are doing PhD under him. Sir has received many awards. Sir has received International Level Outstanding Scientist Award in 2020, National Level INSC Research Excellence Award in 2020, National Level Best Research Paper Award in 2018, Regional Level Shikshan Ratna Award in 2014, State Level Professor A.R. Rao Award for Mathematics Education and Popularization in 2013, State Level Professor B.N. Vyas Prize for the Best Article in Suganitam in 2011. Sir has also worked as Secretary of the Gujarat Ganit Mandal from 2010 to 2018, worked as Chief Editor of Mathematics newsletter Surat during August 2012 to July 2017, whose first issue was presented to Chief Minister Shri Narendra Modi, worked as resource person for BISAC, IGNOU, Babasaheb Ambedkar Open University, Homi Bhabha Center for Science Education, Vikram Sarabhai Community Science Center, Ahmedabad, received minor research project of UGC during 2006 to 8. This is just a brief introduction about him, and he has delivered many plenary talks, research expert talks in 20 national and 13 international conferences, and also delivered more than 60 invited talks. So it's a great pleasure to have you, sir, over here at Paro University. I welcome you, sir, to start with your webinar.
Okay, thank you. So good morning, everyone. So first of all, I am grateful to Paro University and especially to Dr. Ityangini Jala for inviting me and giving me such a nice introduction of me. And inviting me for this online lecture about Ramanujan's life and some of his mammoth work. So about the title of today's lecture, The Man and the Genius Ramanujan. So Ramanujan's life has inspired me from the time when I was a PG student. That was ignited more during 125th birth centenary year of Ramanujan, when I was invited to attend an international conference in 2012, where I got a chance to meet nearly all the stalwarts connected with the work of Ramanujan. So in my today's lecture, in this webinar, I will be presenting the legacy of Ramanujan, who is one of the greatest mathematicians in history. What makes Ramanujan unique is a spectacular and surprising part of almost every one of his discoveries and the manner in which he arrived at his results. So Ramanujan's life story is inspiring, and he has the praise from the world, not just of professional mathematicians, but of students and laymen as well. Indeed, one of the best ways to attract bright young students to mathematics is to expose them to the fascinating world of Ramanujan's mathematics. So April 2020 marked the 100th death anniversary of Ramanujan, who was a decade ahead of his time. Yet, his extraordinary ideas and remarkable life story are still highly influential in mathematics, inspiring both the laymen and to the serious number theorists. So with this is a small initial thing which I want to share. I'll start with my lecture. Our screen visible, sir?
Yes, sir, visible, sir. You can do the full screen also.
Yeah, I've already made the full screen. I don't know whether it is changed or not.
No, it is not changed yet. First slide, sir, the sixth slide is visible.
Already here, but PPT change. I don't know exactly. So I'll do one thing then.
Yeah, now it is visible, sir. The title slide is here.
I've made a full screen, but I think so it is not visible there.
Yes, sir. It's not coming as full screen. But it's okay, sir.
Uh, I'll take just a minute. How visible, sir?
Yes, sir. Now it's visible. Perfect.
Okay, so this is the title of my lecture, The Man and the Genius Ramanujan. So actually this lecture should cover the two things, the main part of Ramanujan, that means the life story of Ramanujan, and the second one, the genius Ramanujan, means its work. But due to time limit, I will focus more on the main part of Ramanujan, about the life story of Ramanujan. So Srinivas Ramanujan Iyengar, he was born on Thursday, 22nd December 1887 at about 6 p.m. at Erode in Tamil Nadu, in Brahmin family. This is the house in Erode where Srinivas Ramanujan was born. And fortunately, I had a chance to visit that house just before 2 years. So the house where Ramanujan lived was you can see that photograph on left hand side. It was repaired in 2003 and it was dedicated to the nation as a memorial by the president of that time, Dr. APJ Abdul Kalam. And on right hand side, you can see the house that is after renovation. His father, Srinivas Iyengar, was an accounting clerk in sari shop. His mother, Komalatammal, earned a very small amount of money as she was just a singer at a local temple. So his mother ensured that family was in tune with Brahmin traditions and culture. So although his family were of very high caste, they were Brahmin, but they were very poor. So by the age of 10, Ramanujan was the top student, not just of his school, but in the whole district. So in 1890, he joined the town high school of Kumbakonam. You can see the photograph of this town high school. When Ramanujan was in a third standard or in his maths class, once is dead. If 3 bananas are district students, idea of division. And he said that an integer divided by itself will always give answer as 1. So, but immediately Ramanujan said, sir, if no banana is distributed to no student, will each student still get a banana? So Ramanujan carry on with this. He said that 0 divided by 0 may be anything. 0 of numerator may be several times 0 of denominator and vice versa. So this shows that he was clear with the concept of indeterminate forms when he was in primary school. So when Ramanujan was in standard 4, his schoolmate of standard 5 gave him one question. And that question he got from one of his friend of standard 6. The question was like this: if square root of x plus y equal to 7 and x plus square root of y is 11, then what are the values of x and y? Here by this we mean the integer values of x and y. So now the question is not at all difficult. It is easy to solve. But just imagine a student of standard 4. Ramanujan was in standard 4. He immediately gave the answer that x is 9 and y is 4. So this was an unexpected achievement by the student of standard 4. So in his school days, Ramanujan was passionately involved with numbers. By the time he was 12 years, he had begun serious self-study of mathematics, working through arithmetic and geometric series and even cubic equations. Ramanujan had discovered his own method of solving equations of 4th degree. So when he was 15 years, one of his collegian friend borrowed him a book from a library, college library. The title of the book was The Synopsis of Elementary Results in Pure and Applied Mathematics. The author was G.S. Carr. You can see the photograph of first page of that book on the first on right hand side. So this book presented a very large number of mathematical results, roughly about 4,000 theorems. But generally it showed very little working. It was packed with so many results, as many as results possible in its pages. And Ramanujan was greatly influenced by this book. You can see the cover of one or two pages of these books. You can see the only results are mentioned here, mostly without any proofs. So Ramanujan was so much influenced by that that when he started writing his own results notebooks, you can see in the Ramanujan's own handwriting, he used to just note down the results without giving any explanation or any proof of that results. So in his notebooks, his earliest record work in the first chapter of his notebook was on magic square. You can see on left hand side, first page of Ramanujan's notebook in his own handwriting. Some more pages. He has given 4x4 and 5x5 magic squares, general formula also for such magic squares. This is one of the magic square which I got from internet. So if you want to construct any 4x4 magic square, then just use this formula. You select 8 constants A, B, C, D and P, Q, R, S in such a way that A plus D is equal to B plus C and P plus R equal to Q plus S. You have to just select the numbers, arbitrary numbers in this way, satisfying this condition. And then substitute that integers in this table. And this is a square which is given to us. And the resultant will be a magic square. So summation of all the rows, summation of all the columns, summation of just diagonal elements. You can see that it is by different colors. So if you add the cells by the colors, you'll get the same answers. So this is what Ramanujan had written when he was in school. And this is Ramanujan's birth centenary magic square. The first row gives the birth date of Ramanujan. Birth centenary magic square, I will say. 22nd December 1987. So here, this is made by selecting A, B, C, D and PQRS as shown here. So in about 1903, while Ramanujan was still in high school, he began to note down in a notebook the results he had found himself. He wrote almost no proofs in his notebook, but the results which he was deriving were astonishing. So in 1903, Ramanujan left high school. At that time, his future was looking very much promising. He considered as the most brilliant student of the whole district. He had won school's mathematics prize also, and so due to that, he got the scholarship also that allowed him to study at government high school in Kumbakonam. Remember, Ramanujan's family was very poor. He was not able to pay the fee of college, but due to this scholarship, he was able to join this college. So Ramanujan entered government's arts college. So unfortunately, because of his excessive obsession with mathematics and neglect of the other subjects, he failed his non-mathematical exams. And so Ramanujan lost his scholarship. So in 1906, Ramanujan set out from Kumbakonam for the first time. And he joined Pachyapas College in Madras in the same class, FA class once again. But again, he got the same result. He failed in all the subjects except mathematics. So he had to, he lost the scholarship, and so he had to discontinue his studies. So however, he appeared for the FA exam externally in 1907. But unfortunately, he failed to pass this exam also. And so this marked the end of his formal education in India. So at that time, he was extremely frustrated. And he even ran away from his home for some time. So this is the letter which his parents wrote to the editor of the magazine, a newspaper, The Hindu. It was published on 6th September 1909. So in an attempt to pull him out of depression, his parents got him married in 1909 to a girl named Janki. Janki was 13 years junior to Ramanujan. So at the beginning of 1907, when he was 19 years old, with minimal funds, Ramanujan continued on the path he had chosen, that is the total devotion to mathematics. The mathematics which Ramanujan was doing was highly original and it was very much advanced. Even though he had very little formal mathematical education, he was able to discover new results. He also independently discovered results which were originally discovered by some of the great mathematicians in history, like Gauss and Euler. So just imagine, at that time, Ramanujan was in such a situation that he could not even spend for plain sheet of papers, which which he need for his research work. So what he used to do, he used to collect the pieces of papers found on the road, and he used to do his research work on all these papers. Just imagine the situation of the mathematician, I will say, the world's greatest mathematician, not at that time, but he was in the pipeline of becoming one of the world's greatest mathematicians. So Ramanujan used to do most of his work on a slate with chalk. So transferring minimal amount of his work, and he used to just write the results which he got in a paper. So Ramanujan's work was, in fact, hard to understand. The style which Ramanujan adopted as a schoolboy after digesting that Carr's book so contributed to the problem, because he used to just write the results without giving any proof. So mostly no one was able to understand how Ramanujan obtained all the results which he was writing. So in 1910, Ramanujan realized that he must find work to stay alive. So in Madras, he found some students. In fact, he went to Madras at that time. He was at Madras. In Madras, he found some students. Madras means the Chennai of today. So he found some students who needed mathematics tutoring. So he also walked around the city offering to do accounting clerk for businesses. So in 1910, Ramanujan tried to find work at Government Revenue Department. And there he met Ramasamy Iyer, to whom Ramanujan showed his notebook. The notebook contained the results of his mathematical work. And Ramanujan's good fortune was that Ramasamy Iyer was a mathematician, in fact, renowned mathematician of that time. Ramasamy Iyer had recently founded the Indian Mathematical Society at that time, and he was so much impressed by looking at Ramanujan's work. So he sent Ramanujan to Madras with a letter of, I think so, he sent Ramanujan to Madras with a letter of introduction to Professor P.V. Shishu Iyer of Presidency College of Madras. Professor Iyer was also equally impressed. So he sent him to a lover of mathematics, Diwan Bahadur Ramchandra Rao, who was the district collector in Nellore at that time. So meanwhile, Shishu Iyer facilitated the publication of Ramanujan's research in Journal of Indian Mathematical Society, which is today also considered as one of the best research journal of India. You can see some of the results of Ramanujan. You can see on the first line, as Ramanujan communicated by Mr. P.V. Shishu Iyer, and the problems are given here. I would like to quote one of his interesting problems. And Ramanujan asked to find the value of square root of 1 plus 2 times square root of 1 plus 3 times square root of 1 and so on. So this infinite nested radicals, he asked to find this value. And no one was able to give the answer. So in the very next issue, Ramanujan gave the answer. That answer is 3, and he even gave the proof of the result. And I'll show what Ramanujan has given there. So he started with the answer. He wrote 3 as square root of 9. 9 he wrote as square root of 1 plus, 9 is wrote as 1 plus 8. 8 then he wrote it as 2 into 4. 4 can be written as root 16. 16 he wrote it as 1 plus 15. 15 is 3 times 5. 5 is written as root 25 and so on. He continued like this. And you can see that you can get infinite nested square roots. And not only that Ramanujan was knowing this result, but he also gave equation to solve infinite nested roots of this type. That x plus n plus a is square root of ax plus n plus a whole square plus and so on. And using this, if you take x equal to 2, n equal to 1 and a equal to 0, we immediately get that result which I have just quoted. Okay. So Ramchandra Rao, Diwan Bahadur Ramchandra Rao, he was the secretary of Indian Mathematical Society at that time, the newly formed IMS. So Ramanujan met Ramchandra Rao, and he helped him to get a clerical position in Madras Port Trust in 1912. So Narayan Iyer, he was the chief accountant of Madras Port Trust. He was very much kind, and he gave Ramanujan a lot of flexibility to pursue mathematics. So Narayan Iyer and the chairman of Madras Port Trust, Sir Francis Spring, they were pressing they began pressing for Ramanujan's mathematical work to be supported by government, and for him to be appointed to a research position at some leading British universities. So, on their encouragement, Ramanujan started writing letters to renowned mathematicians of that time. So, Ramanujan wrote one letter on 16 January 1913 to Professor Hardy, G.H. Hardy. You can see the photograph of Professor Godfrey Harold Hardy, who was a world famous mathematician at that time. And he was a fellow of Royal Society of London and professor of Department of Mathematics at Trinity College, Cambridge. And Professor Hardy was confused over the 9-page of mathematical notes which Ramanujan had sent. You can see the photograph of that Ramanujan's work, Ramanujan's letter, I will say. The work which Ramanujan had sent, they seem to be unbelievable. What followed were at least 11 pages of technical results from a range of various different areas of mathematics. There were even few things that on first sight might seem absurd. Like Ramanujan wrote the result like 1 plus 2 plus 3 and so on is minus 1 by 12, or even 1 cube plus 2 cube plus 3 cube is 1 upon 120, which he got by substituting value of x in one infinite series. But there were statements that suggest a kind of experimental approach to mathematics. You can see in his own Ramanujan's own handwriting. But some of the things got more exotic. With pages of formulas like this, you can see some formulas which Ramanujan wrote in that letter. So Hardy reviewed the papers with J. Littlewood. Littlewood was another eminent Cambridge mathematician and colleague of Professor Hardy. You can see photograph of Hardy and Littlewood. So after spending 2.5 hours together and digesting the extraordinary original work, both these mathematicians came to a conclusion that they were looking at the papers of a mathematical genius. It was like a lotus in a pond. So this was one of the continued fraction which was written in the Ramanujan's letter. It is like e raised to minus 2 pi by 5 upon 1 plus, and then 1 plus, the next term is e raised to minus 2 pi upon 1 plus, again it continues like infinite. So it is called infinite continued fraction. And Ramanujan gave the answer of this as square root of 5 plus root 5 by 2 minus root 5 plus 1 by 2. So of these and some other formulas in that letter, Hardy once said in 1937 that they defeated me completely. I had never seen anything in the least like them before. A single look at them is enough to show that they could only be written by a mathematician of the highest class. But they must be true, because if they were not true, no one would have the imagination to invent them. This is what Hardy said about the results of Ramanujan from that letter. So Professor Hardy recognized Ramanujan's mathematical ability, and he replied back on 8th February 1913. This is the photo of that historic letter by Hardy. So meanwhile, Hardy was not the first eminent mathematician to whom Ramanujan sent his manuscript. There were two other before him, Hobson and Baker. You can see their photograph. Both were English, both of highest professional standard. But they had each written the manuscript without any comments. So meanwhile, on 25th February 1913, when G.T. Walker, he visited Madras Port Trust from London, Sir Francis Spring showed him Hardy's letter and Ramanujan's notebooks. So Walker was very much impressed So he immediately wrote a letter to Madras University and asking for financial support to Ramanujan, and which immediately was granted. So Madras University granted a full-time scholarship to Ramanujan to continue his research. So this enabled Ramanujan to devote his full time to research work. So in 1913, by 1913, his research potential began to be realized. So meanwhile, a very interesting correspondence went on between Professor Hardy and Ramanujan. Hardy was eager for Ramanujan to come to Cambridge at that time. But in accordance with his Brahmin beliefs, Ramanujan refused to travel overseas because mainly due to his mother. She strictly said that no one from our family, Brahmin family, can cross the seas. So at that time, arrangements were made to fund 2 years of his work at the University of Madras. So Professor G. H. Neville was a fellow of Trinity College, Cambridge. He was visiting the University of Madras in January 1914. So Hardy assigned the task to Neville to encourage Ramanujan to go to Cambridge. Professor Neville met Ramanujan, his mother also, and he was able to convince his family, especially his mother. So after some resistance from family, Ramanujan was finally permitted to go to England. So Professor Hardy arranged for him to come to Cambridge. He took charge of his financial support, and he gave financial support and everything. So Ramanujan changed his hairstyle from traditional Brahmin style of a tuft to the English crop, equipped himself with Western dresses, and he prepared for his departure to England. So Ramanujan left Madras by the ship SS Nevasa. You can see the photograph of that ship on 17 March 1914. He reached London on 14th April 1914. That was the time just 3 months before the start of World War I. So after Ramanujan reached Oxford University, Hardy and Littlewood both examined all the notebooks of Ramanujan in detail. In fact, both the notebooks, 3 notebooks of Ramanujan. And what they were able to discover was even more amazing than what they had believed from their previous correspondence with Ramanujan. The notebooks which Ramanujan had brought with him from India, they were filled with thousands of identities, equations, and theorems, which Ramanujan had discovered for himself in the years 1903 to 1914. You can see the 3 notebooks of Ramanujan, the photograph of that. Right now it is in possession with Madras University. So some of the results which Ramanujan had written in his notebook were discovered by earlier mathematicians. Some, though he was, as he was inexperienced, were mistaken, but mostly many of the results were entirely new. So here was someone without any formal education beyond high school, coming up with some of the most surprising discoveries in entire history of mathematics. So Ramanujan had very little formal training in mathematics, and indeed large areas of mathematics were unknown to him. So once Ramanujan said that the goddess Namgiri used to appear in his own dreams, and many of the results were written on the screen by goddess, and they stuck to his mind as soon as he woke up, and he used to write the results. Anyway, this is the place, Bishop's Hall in Cambridge, where Ramanujan lived in the building, which you can see on the right hand side, during the 1915 to 1917. So when he was in Cambridge, although the culture, climate, and food were very different from those he was habituated to, Ramanujan settled there into steady research with Hardy. He remained vegetarian throughout, and he even cooked his own food. So this is a copy of a letter which Ramanujan wrote to his friend R. Krishna Rao, and this is a copy of letter which he wrote to his mother. It is in Tamil. So during 5 years of his stay in Cambridge, he published 21 research papers. You can see the number of research papers year-wise during his stay. So one of his longest research paper was entitled Highly Composite Number. It appeared in Journal of London Mathematical Society in 1915. It was 62 pages long, which contained about 269 equations. So in March 1916, Ramanujan was awarded the BA by research degree for his work on highly composite number. Remember, this is not BA which you know in today's world. Ramanujan had not went to any, he has not taken any courses, he has not passed any exam, but still he got this BA degree by research. And later on, this degree was renamed as PhD by Cambridge University. So indirectly, we can say that Ramanujan got a PhD degree, but not officially PhD. At that time, it was just a BA degree. So Ramanujan, who had been a college dropout at Madras earlier, received the highest valued BA degree equivalent to PhD of Cambridge University, based not on any coursework or examination from which he had been exempted, but on the basis of his published research work. That was one of his outstanding achievements in Cambridge. This is a rare photograph of Ramanujan. You can see Ramanujan in center and Professor Hardy at extreme right. So in February 1918, Ramanujan was elected as a Fellow of Royal Society of London. So historically, the Fellow of Royal Society, that is FRS, is the highest academic honor a scientist can get in England. And it is considered as next to Nobel Prize. So on 13th October 1918, Ramanujan was elected as a Fellow of Trinity College in Cambridge. So he was offered £250 annually for 6 years. And he was the first Indian to receive both these achievements. So due to his intuition and computational ability, the name of this natural genius was already placed at that time with an all-time great mathematicians like Euler, Gauss, and Jacobi. So although his health was reasonably good for the first 3 years in Cambridge, later his health deteriorated rapidly. He suffered from night fever, depression, weight loss, and hysteria so severe that he once even tried to commit suicide in 1918. So he was missing his family and even a homeland. So in May 1917, he was admitted to hospital for 5 months. Hospital, in a sense, it was a sanatorium, which a kind of a hospital, you can say. So when he was in hospital, in sanatorium in England, Professor Hardy visited Ramanujan in hospital. So when Hardy just casually remarked that he had taken a taxi number 1729, what an uninteresting number, as Hardy said. So Ramanujan immediately responded that the number 1729 is not a dull number. It was quite a remarkable number. He continued to say that it is the smallest integer that can be represented in 2 ways as sum of 2 cubes. By this, he meant to say that 1729 can be written as 1 cube plus 12 cube and 9 cube plus 10 cube. And it is the smallest such number, so that we can write it in 2 ways. Does not mean that Ramanujan was fond of this number 1729. In fact, every number was friend of Ramanujan. That was said by Professor Littlewood. And this is not that by particular fluke he was knowing the property of this number. In his notebooks, he wrote this result. You can see here some of the results: a n cube plus b n cube equal to c n cube plus minus 1 raised to n, and so on. So from that, he got several different results. So he had a small connection with Fermat's theorem also. Fermat's theorem is considered as one of the most famous unsolved theorem. It was unsolved for more than 350 years. The theorem is the equation x is to n plus y is to n equal to z is to n has no integer solutions for n greater than 2. non-trivial solutions, in fact. From that, the special case is x cube plus y cube equal to z cube. These had no solution. And Ramanujan found an infinitely family of positive whole number triplets xyz that were nearly but not quite satisfy Fermat's equation for n equal to 3. That means just emit by 1 or minus 1. By that I mean to say that, see the last line, he used to solve the equation x cube plus y cube equal to z cube plus 1 or x cube plus y cube equal to z cube minus 1. Euler at once asked to find positive or negative rational solutions of equations a cube plus b cube plus c cube equal to d cube. So for this equation, Ramanujan had given a set of solutions like this, parametric solution. And in that, this solution, if you take alpha, beta, gamma, and lambda as 3, 0, 1, and 3 respectively, then we immediately get 12 cube plus 1 cube equal to n cube plus 9 cube. That is same as 1729. Anyway, this is the sanatorium where 1729 incident took place. And later on, it was just broken completely. 5 years in a cold country, in a lack of vegetarian food in wartime, England had wrecked Ramanujan's health. And so Ramanujan wanted to return back to India. So Ramanujan sailed for India on 27 February 1919. And 4 weeks later, on 27th March, he arrived at Bombay. And soon after, he arrived in Madras on 2nd April 1919. At that time, he was very much thin and weak, but with a scientific reputation such as no Indian has enjoyed ever before. So numerous felicitations and honors showered upon him from all quarters in Madras, including a professorship at a university, which he had not even able to dream of joining even as a student. So after his return, University of Madras granted him a scholarship of £250 a year for 5 years. But most unfortunately, his health did not improve on his return to India. It was very much clear to his old friends and admirers what was coming up. They tried to support him as much as possible. Probably he was having tuberculosis or even cancer. While on the deathbed, he did a lot of work. He wrote down 600 formulae on loose sheet of papers during the last year. This work was considerable as one of the most brilliant work of Ramanujan. We'll see this later on. So unaffected by all the pains, Ramanujan got busy with work in a reclining position at a furious pace, as Ramanujan was knowing that his end is coming. So he kept noting down new results on Mach theta functions on new sheets of papers. I'll not go in detail about what is Mach theta functions. The last and only letter he wrote to Hardy from India was after his return was on 12 January 1920. That was 4 months before his demise, which contained no news about his declining health, but had only information about his original work on Mach theta functions. The major portion of lost notebook, I'll say what is the lost notebook? It is devoted to Mach theta functions. So according to Professor Andrews, the last brilliant creation of Ramanujan that continued to make waves even in recent years. I'll skip about Mach theta function. It has application in various fields. So despite all tender attention he could get from his wife and the best medical attention from the doctors, his untimely end came on 26 April 1920 at Madras, when Ramanujan was 32 years, 4 months, and 4 days old. This is the house where Ramanujan took his last breaths. And this is the letter written by Ramanujan's brother after his death. And this is a telegram which was sent to Professor Hardy by Madras University on his demise. After Ramanujan's death in 1923, the University of Madras sent his final work, written on a sheet of papers, to Professor Hardy. In 1923, Hardy spent 3 to 4 months on the second notebook of Ramanujan on hypergeometric series. An introduction to the papers is published. So he wrote that systematic verification of results would be a very heavy undertaking. So after that, Hardy decided to go back to his original research work. And so Professor G.N. Watson was requested by Madras University in 1931 to edit the notebooks of Ramanujan in a suitable form for publication. And this was a really challenging task since the notebook was containing about 4,000 theorems. So he started the working on this, but he was not able to do more work on his notebooks. So when Watson died in 1965, the Scottish mathematician Robert Rankin collected all the papers from Watson office and sent to the Wren Library in Trinity College, Cambridge for preservation. And then it was forgotten. No one was even remembering that the paper contained one of the best results, not only of Ramanujan, but of entire mathematics. So unknowingly, the last manuscript of Ramanujan was in this collection, and it was placed in the Wren Library and it was forgotten. So a decade later in 1976, when Professor George Andrews was searching in Wren Library, he discovered a box of these papers. And there he found this work of Ramanujan. So these are now referred to as content of Lost Notebook of Ramanujan. And then Professor Andrews published in the form of a notebook. So what are the legacy of Ramanujan? So contribution of Ramanujan in different area of mathematics, as you can see. He contributed in magic squares, sum of series, polynomials. One of the best, his best contribution is in partition theory, elliptical functions, even in formulas of pi, combinatorial analysis, continued fractions, highly composite numbers, hypergeometric series, even some properties of primes, and many more. So essentially, Ramanujan's legacy consists of 4,000 formulas on 400 pages, filling 3 volumes of notes, all densely packed with theorems of unbelievable powers, but mostly without any proof. If someone asks that, is there any theory of Ramanujan? So no, there is no theory of Ramanujan. But he gave mathematical structures that are now important to modern day research. In one of his published manuscripts, Ramanujan recorded a lot of elementary looking results related to congruencies. In 1960, Jean-Pierre Serre, who was a field medalist, revisited some of these results, and in them he found a glimpse of theory of what he named the theory of Galois representation. And this theory of Galois representations is a language that Andrew Wiles used in 1990s to prove Fermat's last theorem. So during last 40 years, there have been many admirers of Ramanujan, out of which the remarkable leading mathematicians are Professor George Andrews of Pennsylvania University, Professor Bruce Bunt of Illinois University, Professor Richard Askey of Wisconsin University, and Professor Ken Ono of Wisconsin Madison University. Through their enthusiasm, determination, and Herculean efforts, each in their own way, they have succeeded in giving fresh motivation to work in areas which were of interest of Ramanujan. The formidable task of truly editing the notebooks of Ramanujan is being done by Professor Bruce Bunt, who had been publishing a series of books since 1981. Professor George Andrews, who accidentally came across 146 of Ramanujan's handwriting, which contains 600 formulas, is considered as discoverer of Lost Notebook of Ramanujan. And Professor Richard Askey, whose enthusiasm and effort helped to prepare bronze busts of Ramanujan throughout the world. Professor Ken Ono, he expanded Ramanujan's partition congruencies and has made important contributions to the theory of Ramanujan's mock theta functions. Fortunately, I had a chance to meet all these stalwarts. This is my photograph with Professor George Andrews. I met him twice. Professor Askey. With all the 3 legends together, with Professor Ken Ono. Okay, no account of Ramanujan is complete without a discussion of his mentor G.H. Hardy. The brilliance of Ramanujan combined with cleverness of Hardy was the key to their successful collaboration. So the role of Hardy in the life and career of Ramanujan is immense, unmatched, and beyond praise. Hardy considered Ramanujan was in a way his discovery. So, meanwhile, some reporter once asked Professor Hardy that what is your greatest contribution to mathematics, and he was expecting some of the results which were discovered by Hardy. But Hardy stated that the discovery of Ramanujan is my greatest contribution to mathematics. So after about a year and a half of Ramanujan stay at Cambridge, Hardy wrote a letter to Madras University. He wrote that Ramanujan is beyond question the best Indian mathematician of modern times. He will always be rather strange, but of his extraordinary gifts there can be no questions. In some ways, he is the most remarkable mathematician I have ever known. So Hardy once said that the real tragedy with Ramanujan's life was not his early death at the age of 32, but that during his most formative years, Ramanujan was sidetracked due to lack of formal training. So once Hardy rated himself and other prominent mathematicians on pure talent scale from 0 to 100. Hardy gave himself a score of 25. His colleague Littlewood score of 30. The great German mathematician David Hilbert 80. But only to Ramanujan he gave 100 out of 100. Another renowned Hungarian mathematician Paul Liddos, he said that he was greatly inspired by Ramanujan's work. He said Ramanujan's contribution to number theory in collaboration with Hardy formed the basis of his work, which led to the creation of probabilistic number theory. So Hardy was of opinion that education would not have made Ramanujan a great mathematician. However, Professor Liddos expressed the view that education would have proved a great deal more for Ramanujan. He would not have wasted so much time rediscovering the work of other mathematicians. Anyway, Ramanujan's mathematics remained fresh even in modern world of computer. He obtained so many different series of pi that are now used in present-day computations, and the value of pi is calculated to several million decimal places. These are some of the results which Ramanujan gave for pi. Pi he expressed as infinite series. These are some more results, and these are some results in his own handwriting from his notebooks. And about the notebooks of Ramanujan. So Srinivas Ramanujan's handwritten notebooks are right now in possession of University of Madras Library. These are a photograph of some of his pages, and each of the pages of these notebooks, they are chemically treated. So we can see that yellowish tone of each of these pages. And this is what Ramanujan wrote in his own handwriting. The second edition of notebooks of Ramanujan were launched on occasion of 125th birth anniversary celebrations. You can see that volume of the notebooks which were published. These are the inside pages of these notebooks, and fortunately I got the chance to go through these notebooks. There's my photograph with that second edition of that notebook. There are only 4 available photographs of Srinivas Ramanujan. This is the first photograph. This is the passport photograph of Ramanujan. I mean, the photograph when you used to come from, went for Cambridge from India. At that time, for passport, used to take this photograph. This is the second photograph at Cambridge University. With some of his friends there. This is one more photograph. And this is the final photograph which I have already shown you after he got his BA degree. One movie was released on 5th May 2016, The Man Who Knew Infinity. Dev Patel played the role of Ramanujan, and Jeremy Irons played the role of Hardy. This is one of the best movie which I have seen in my life. So I'll suggest everyone to see this movie if they have not seen this. The movie is based on the book written by Professor Robert Kanigal. The title of the book itself is The Man Who Knew Infinity. So my last words now. Ramanujan is admired for having achieved so much in such a short lifetime that was filled with the barriers of poverty and who did outstanding work under the most challenging circumstances. So what makes Ramanujan unique is that in spite of the limitations and orthodox traditions that surrounded him, this untutored genius produced mathematics of the very highest quality. Mathematics has grown so vast and complex that it is unlikely that a Ramanujan-like phenomena will ever happen again, as it will be difficult to make fundamental contributions without a clear understanding of connections between different fields. Ramanujan had also raised several fundamental questions that have engaged mathematicians for decades. Some of his work have created fruitful areas of research, such as probabilistic number theory. So Ramanujan lives today through the many questions he has raised. So Ramanujan has left behind enough ideas to keep mathematicians busy well into the 21st century. It will take many more decades to completely understand Ramanujan's contribution. We should be grateful to Ramanujan not only for discovering so much, but also for providing others plenty to discover. So this completes my lecture. I have just tried to cover the life part of Ramanujan without giving much mathematical, showing his mathematical discoveries by Ramanujan. And this is my last slide. This is a quote which Ramanujan has given. An equation means nothing to me unless it expresses a thought of God. This is the reference book which I have used for some of the slides. It's a very nice book by Krishnasamy Aladi. So thank you, everyone. So
Thank you so much, sir. I would like to thank sir for the Genius Ramanujan. The presentation was very interesting and we got to know in detail about him. Thank you so much, sir, and everyone who are part of this webinar. I'd like to invite if someone has some questions. I think there are no questions, sir. It was totally informative talk. Thank you so much, sir.
So it was my pleasure. Thank you.
Yeah, welcome, sir.